Today we are doing lesson 1.2. We're going to be talking about piecewise functions. Piecewise functions. That's our topic for today, piecewise functions. So first of all, a piecewise function is a function that is defined by two or more equations. Each piece of the function has a different part of the domain attached to it. We're going to look at this example right here. F of x equals. Notice there are two pieces of the graph. Let's look at them one at a time. So the first piece, y equals x minus 2 if x is less than or equal to 0. Let's take a look at the graph. Here's that piece, y equals x minus 2 if x is less than or equal to 0. Now that equation, y equals x minus 2, represents a line with its y-intercept at -2, but we're only interested in that part where x is 0 or less. So x equals 0, x equals -1, x equals -2, x equals -3, and so forth and so forth. That's one piece of the graph. The other piece, y equals 2x plus 1 if x is greater than 0, right here, y equals 2x plus 1 if x is greater than 0. Notice on this one, we follow the line y equals 2x plus 1. There's his y-intercept at 1. There's a little open circle there. That's because our inequality says x has to be strictly greater than 0. So we don't include the y-intercept. You leave a little open circle there. But we follow it across those x values that are greater than 0. Notice on the other half of the graph, we had a solid point right there because the inequality included the 0. So closed as opposed to open on the other piece. Now we're going to dive down into example 1 and talk about evaluating this same piecewise function. So we're sticking with the same function, but we're going to talk about evaluating. So on the first part, evaluate the function f when x equals 0. First thing we have to do is notice that x equals 0 fits in the first piece, or the first part, the first equation there. So we work with f of x equals x minus 2, and we plug x equals 0 into that because 0 is less than or equal to 0. That's where it fits in the domain. So f of 0 is going to be 0 take away -2, which is -2. So the value of f is -2 when x equals 0. All right, for the second part, part B, we're going to switch because now when x is 4, we now have something that's greater than 0. 4 is greater than 0, so we have to plug it into the other part, or the other piece. So we do f of 4 and plug it into the equation 2x plus 1, y equals 2x plus 1. So we do 2 times 4 plus 1, that's 8 plus 1, which is 9. So the value of f is 9 when x is 4. I'm going to help you out with the first couple of problems on the monitoring progress. So we're going to look at number 1, f of -8, given that we have a function defined with 3 pieces. So 1, 2, 3 pieces. What we first look at when we're evaluating this function, and we want to find f of -8, we're first going to notice that -8 is smaller than -2, and because -8 is less than -2, we're going to use that first part or first piece of the function. Now what that one says is f of x is equal to 3 if x is less than -2. So that first one is 3. This is going to be 3 for any x value less than -2. All right, let's look at the second one. F of -2. -2, where does it fit in our domain restrictions. -2 is between -2 and 5. And notice I can't use the first one because it says less than -2. -2 is equal to -2. So I have to use this piece right here, the second piece. So we're going to use the equation x plus 2, y equals x plus 2. And we're going to stuff in a -2. So -2 plus 2, which is 0. And that's how we evaluate.